All right, guys, so today we are going to talk about combining like terms. So if you think back to the notes that we took a couple days ago, we talked about what like terms were. And remember, like terms are terms that have the same variable, and they are also raised to the same power. So we're going to do this first example together. The example says a plus 3b plus 10 plus b plus 2a. So what we're going to do is we're going to start from the back of our expression, and we're going to use the train method, and we're going to box the terms from the back forward, and we are going to include the sign that is to the left of the term, or in front of it, okay? This isn't very pretty, but down here it's done very nicely. So we have just A in a box by itself, we have plus 3b in a box by itself, we have plus 10 in a box by itself, and so forth. Okay, so we've kind of separated the terms. Now, the next thing that we're going to do is rewrite this expression using the commutative property. So we're just going to rewrite it in a different order, but it still means the same thing. So how we're going to write it, though, is we're going to make sure that our like terms are next to each other. So if you see in the boxes, we have an A and a 2A, a plus 2A. So we're going to put those two next to each other down here in our new expression. We're going to put our like terms next to each other. Okay, if we go back, we don't have any more A's, so we're not going to write any more A's. If we go back to our boxes, we've got a 3B and a B, so we've got like terms there, so we're going to write those next to each other. And then this 10, there's not a like term in this expression, so we're just going to rewrite the 10. Okay, so once we do this, when we say combine like terms, we are doing just that. We are combining, or we are adding our like terms. So remember, there's an imaginary 1 right here in front of that A, and if you look at the B down here, there's also an imaginary 1 in front of that B, so don't forget that. But if you look at just our A's right now, we have 1A plus 2A. Well, if we combine those together, or add them, we get a total of 3A. Okay? Now we're going to look at our next set of like terms. We've got 3B and 1B. If we combine those together, we would get a total of 4B. And then, like we said, the 10 doesn't have anything else to combine to, so we're just going to rewrite that. Okay? So what we did, we combined our like terms, and we made a simplified expression from the original one. Now, I just want to make sure that we're clear here. We don't combine unlike terms. So you would never combine a 3A and a 4B, because those are unlike terms. You can only combine like terms. Okay? So we're going to go ahead and go through 1 through 9 together. So follow along with me and make sure that you're showing the same work that I'm showing on my screen. Okay, so if we look at number 1, we're going to do the same thing. It says 12m plus 15b plus 2m plus b plus 7. And we're going to combine like terms. So again, use the train method and box your terms starting from the back, including the sign in front of it. And then we are going to rewrite it with our like terms next to each other using the commutative property. So we have 12m plus 2m, and then we've got 15b plus b, and then we have a plus 7. So I put my m's together and I put my b's together, and then we've got 7, which is kind of solo at the end. Okay, so now I'm going to look at just my m's, my first pair of like terms, and I'm going to combine them. 12 and 2 would give me 14m. Plus, we've got 15 and just b, which is 1b, so that would give us 16b. And then 7's kind of off here on its own, so we can't combine it with anything. It's just going to be brought down 7. So our original problem has now been simplified to 14m plus 16b plus 7. All right, let's take a look at number 2. So we have 45x plus 12y plus 16 plus y plus xy. So again, we're going to start with boxing our terms using the train method. Okay, rewrite it so that your terms are together. So I'm going to start with my y's, so I've got 12y plus y. And then I've got, so those are together. When I look at my x's, my 45x, I don't have another one that's just x. So I'm just going to bring down 45x. Okay. Again, when I look at my constant 16, I don't have any other constants, so I'm also just going to rewrite that. And then here I've got 1xy, but I don't have any other just xy's, so I'm going to just bring that one down as well. Okay? So now that I've written them together, I am going to look and combine my like terms. So I've got my y's right here. I've got a 12y plus a 1y. That would give me 13y. And then like we said earlier, these last three terms don't have anything else that you can combine with it. So we're just going to rewrite everything else again because there's nothing more that we can do to simplify those. There are no other like terms that go with them. So this would be my simplified answer. All we did was combine 12y and 1y to get 13y, and then we rewrote everything else. All right, so number 3 is 16 plus 24m plus n plus 7n squared plus 8 plus 20n. So again, start by boxing your terms using the train method. Okay, and then rewrite them so that your terms are together. Does not matter what order you put it in, just as long as they're together. So I'm going to do my 16 and my 8. Those are both constants and they are like terms. So 16 plus 8. I'm going to do my n's next. So plus n plus 20n. And then I've got an m. There's no other just m's here, so I'm just going to rewrite 24m. And then this n here is raised to the second power, and there's no other n's raised to the second power, so there are no other like terms in this expression. So I'm just going to also rewrite 7n squared. Remember, it doesn't matter what order you write in because we are working with addition. Now that we've got our like terms next to each other, let's go ahead and combine. So we've got 16 plus 8, which would give us 24. We've got our like term n's right here. Remember, there is a 1 in front of that. So we have plus 21n because it is 1n plus 20n. Remember, we said there are no other m's here. So we are just going to rewrite 24m. And then there are no other n squared. So we're going to write plus 7n squared. And this would be completely simplified. Again, it does not matter what order you write it in. Okay, for this next one, we are going to simplify the same way. We're going to box from the back going forward. We have a pair of like terms with our x's. We've got a 5x plus a 2x. And then we have like terms with our constants, the 6 and the 2. So plus 6 and plus 2. So when we combine like terms, our x's, our 5x and our 2x become 7x plus, and our 6 and our 2 become 8. And we're done. Okay, for number 5, same thing. Rewrite it as 3 plus 6 plus 5m. Our 6 and our 3 will combine to give us 9. And our 5m, there's nothing to combine it with, so we're just going to rewrite plus 5m. I do want to point out, you can, just like the rest of them, you could write it as 5m plus 9. Both of them are correct. Now, if you look at number 6, this one's a little bit different, okay? The ones that we've had previously have all been plus, 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 plus. This one has a little dot, which remember, that means to multiply, okay? So this says b times b times b. Well, if you think about it, pretend those were numbers instead of variables. Pretend it was really 3 times 3 times 3. We talked about how if it's written where it's repeated multiplication, you could just write this as 3 to the 3rd power. Well, the same is true for variables. Since it's b times b times b, you would simplify this and just write it as b to the 3rd power. Now, the way this is different from what we have been doing, if these were plus signs, so instead of multiplication signs, so if the problem was actually b plus b plus b, since they are all like terms and they all have that 1 in front of them, 1b plus 1b plus 1b would simplify to 3b, okay? This answer is different than the one that we got before. So just be careful if there's multiplication, repeated multiplication, you can make it into an exponent. And then if there's plus signs, you're going to be doing what we've been practicing today. Okay, so for these next two, again, continue to do it the exact same way you have been doing it. We have two that are just constants, our 6 and our 5. So I'm going to write 6 plus 5. And then we have a 1k, a 3k, and another 1k. So let's add that. 1k, 3k, and another 1k. Okay, so to combine them, we've got our 6 plus 5, which would give us 11. And then we have 1k plus 3k plus 1k, which would give us a total of 5k. Okay, for number 8, same thing, make those boxes. Our like terms here, we've got 3x plus 4x. And then we have a plus 10x squared, which is not a like term with our 3x and our 4x. It's separate because it's raised to a different power. So when we combine our like terms, we've got 3x and 4x, which would give us 7x. And then we have plus, we're going to just rewrite 10x squared. Go ahead and flip your paper over, and we are going to do number 9 together. All right, so number 9 just has variables. So what I would do first is just make sure to remember that there are those 1s in front of all of them. And then we are going to still box them from the back forward. Okay, so I've got an H, a 1H, and then plus 1N plus 1N. So as you can see there, I've got two like terms. I've got my N's, so 1N plus 1N. And then this H, there's no other H's in this expression, so we're just going to write plus 1H. Then when we combine, we can only combine the N's together here. So we have 2N, because 1N plus 1N is 2N. And then we will just rewrite the plus 1H. I want you to finish the rest of this page, so 10 through 18. And when you are done, I want you to check the key that is on our unit plan to make sure that you got your answers correct. Good luck.